Okay, geometry fans, our topic for today, this is section 3-3, transformations, and we're going to talk about rotations and dilations. Before we start, let me tell you your joke of the day. Why wouldn't the shrimp share his treasure? And the answer, because he was a little shellfish. Selfish, shellfish, get it? Okay. So our goals after this lesson, students should be able to rotate an object and determine whether a figure has been translated, reflected, or rotated. And we'll also put dilated in there as well. So in the first section though, it says recall. We're going to do a little review. For each of the following, write the ordered pair for the image of point A, -3, 5, after the reflection. And we're going to reflect across the x-axis, the y-axis, the origin, and some lines. So -3, 5 has already been plotted, so there's A. If we reflect across the x-axis, now the x-axis is here. Okay, so that means if we are above the line, we're going to reflect it, so we are below the line. And remember that with reflections, you have to be the same distance from the line of reflection. So from point A, I would count 1, 2, 3, 4, 5 spaces to get to the x-axis. So I'd go 1, 2, 3, 4, 5 on the other side. So there's the point. I'll call that A prime. And that would be -3, -5. That's the ordered pair. So -3, -5. Now, let's reflect A across the y-axis. So here's the pre-image. Across the y-axis means we're going to reflect to the right. So I'm going to count perpendicular to the y-axis, so that's horizontal, 1, 2, 3 to get to the line, 1, 2, 3 on the other side, and I'll call that B because that's for part B there. So the image of A after the reflection across the y-axis is 3, 5. C is across the origin. So that's 0, 0, so it's kind of like a slanted reflection. And what's going to happen, we're in the second quadrant, so if we reflect across the origin, we'll be in the fourth quadrant, and it'll be the same distance from the origin, just in a different quadrant. So left 3, up 5, will go right 3, down 5. So this, again, the same position, just in a different quadrant. So horizontal change would be 3, and the vertical change would be 5. Okay? I'll call that point C. That is 3, -5 for the coordinates. Okay, and now we'll go across a couple of lines. So let's take across the line x equals -1. Now that is a vertical line. So on the x-axis, here's -1. I'm going to draw the vertical line there. If you use a ruler, that's probably better. X equals -1. Now, since that's a vertical line, we're going to count horizontally to make that perpendicular, 90 degrees. Now from point A, though, that is 2 spaces to get to the line of reflection. I am ignoring the y-axis. I'm pretending it's not even there. 1, 2 to get to the line, and then that means go 2 spaces, 1, 2 on the other side. Okay, so there is point D. So 1, 2, that is 1 and 2. So that's 1, 5. So there's part D. Okay, part E is across the line y equals 2. That's horizontal. So on the y-axis, I find here's +2. I'm going to draw a horizontal line. Okay, so since we are above the line, when I reflect it, we will end up below 1, 2, 3, and then from there, 1, 2, 3, and we're at -3, -1. So there's point E, -3, -1. Okay, the last one is across the line y equals x. That line is the slanted line that goes through the origin, and then 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, -1, -1, -2, -2, -3, -3, and so on. Oh, that's terrible. Okay, that's a little better. There's y equals x. It's where x and y are the same. 1, 1, 2, 2, negative 3, negative 3. Okay? Now, to reflect that, the easy way is to take the point for A, switch x and y, and change the signs. So switch x and y, and so, oh, actually, we don't need to change the signs. Just switch x and y. Sorry about that. So negative 3, 5 becomes 5, negative 3. Positive 5, negative 3, and that's F. And notice that if I were to connect that, that does look like it would create a perpendicular. So just switch your x and y values. Negative 3, 5 becomes 5, negative 3. And that would be the solution for that. Now the other way though, you can count this. Remember that perpendicular lines are opposite reciprocals. What I'm going to do, this slope here is positive 1. That's y equals 1x. So the slope is 1 over 1. The opposite reciprocal would be negative 1 over 1. Okay? So the way that I can do that, though, is if I count, I'm going to count across and then down. And however many spaces I go across, I will do the same down. 1, 2, 3, 4, 5, 6, 7, 8 to get to the line. And then I'll go down 1, 2, 3, 4, 5, 6, 7, 8. Look at where it puts me. If you want to think of it as the slope, actually, you might be thinking, well, isn't rise over run up or down first? I could have gone down from A. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll go right. 1, 2, 3, 4, 5, 6, 7, 8. If you think of it as a fraction, negative 8 over 8 reduces to negative 1. Okay, so the easy way is just to remember switch x and y. That's the quick way, but you can count it at the same time. Okay, so that's kind of a long review there, but that is reflections. So let's talk rotations now. So we're going to come down to number 2. On the side here, you see this shape, and you'll notice that there are 8 points, 8 vertices, okay? A, B, C, D. And this is called an octagon. An 8-sided figure is an octagon. Now, what we're going to assume about this figure, notice we have the point here. That's going to be the center. We will assume that all of these are equal. Each side is equal. And we will assume that all these angle measures are going to be congruent as well. So, what is the image of point A? So we're going to start at A. After a 90-degree clockwise rotation. So imagine that we take this octagon and we spin around the center. Okay, so each of these points, they're all going to spin. Now, like I said, we're going to assume that all the sides are congruent and all these angles are congruent. So the other thing I'm going to do is draw what is called central angles. So from the center, I'm going to draw these angles, okay? Now, the total here would have to be 360 degrees. Well, if I take 360 and I divide by 8, because there are 8 of these, what we get is 45 degrees. So each of these is worth 45 degrees. Now, if you want to think of it in a different way, you can kind of see, if you look around the edges, this kind of circular object. Now, we haven't talked about circles yet, but again, if the central angle is 45, then the outer arc measure, these are also 45 degrees. Okay, I'm not talking about circumference, I'm talking about arc measure. Okay, so what do they want? Well, what's the image of point A after a 90-degree clockwise rotation? Clockwise means you're going this way. Counterclockwise means you're going the opposite way of reading a clock. So 90 degrees, starting from A, the question is how many 45s would make 90 degrees? And in this case, well, 90 divided by 45 is 2. So what's going to happen is A is going to move 2 positions. It's going to land on a different point in a different place. If I move 2 places clockwise, 1, 2, we end up at C. So a 90 degrees clockwise rotation puts you on point C. 90 degrees counterclockwise, starting at A, counterclockwise is this way. Now again, to get to 90, that's 45 and 45. So that's 2 moves. 1, 2. So where do we end up? G. That's all you're doing. You're figuring out how many spaces to move and where do we end up. 135 degrees clockwise. Well, 135, if each move is 45, you can do a little division here. How many 45s make 135? That's 3. So clockwise, 1, 2, 3 spaces. We end up on D. 225 counterclockwise. Well, how many 45s get you 225? That would be 5. Now counterclockwise means we're going this way. So from A, we're going to count 1, 2, 3, 4, 5, and we end up again on D. Now it's kind of interesting because you end up in the same place for both of these, but if you add 135 and 225, notice that puts you at 360. So it's basically going opposite directions to make one full circle. Now 180 degree rotation. Notice there's no clockwise or counterclockwise, and that's because 180 is halfway. If you take 180, the whole circle is 360, so 180 is halfway. It doesn't matter which way you move. 180 divided by 45 is 4 moves. So if I go clockwise, 1, 2, 3, 4, I end up on E. But if I went counterclockwise, 1, 2, 3, 4, I end up on E, same place. Okay, and then 405 clockwise. Now that's actually 9 moves. And you might say, well, wait a minute. There are only 8 points. There are 8 vertices in an octagon. What's going to happen is we're going to go around more than one full time. So if I count, clockwise is this way. 1, 2, 3, 4, 5, 6, 7, 8 gets me back to A, and then 9 puts me on B. Okay, and that's it. That's how we're doing it. In number 3, we have a different shape. This is a hexagon. You have 6 sides. Now, again, all the angles add up to 360, okay, from the center. But this time, since there are only 6 vertices, okay, each piece here is 60 degrees instead of 45 degrees. So now you're going to count with 60s. So we'll go 120 degrees counterclockwise. And what's the image of point F? So we start with F, which is here. 120 counterclockwise, well, that's 2 moves. 120 divided by 60 is 2. Counterclockwise, 1, 2. Puts you at B. 300, okay, how many 60s make 300? That's 5. Clockwise from F, 1, 2, 3, 4, 5. So that's point A. Now the last one is a little different. If you reflect point F across BE, line BE, so here's line BE. So if we reflect point F, what would be its image? Now I'm going to turn this a little bit to make it look vertical. You're going to be tempted to say that C is opposite point F, but if I reflect it, remember, reflection means creating a perpendicular. Think of this as a vertical line. That means I would draw a horizontal. Look at the point where we end up at. That's going to be point D. So the answer, if you reflect point F across line BE, what would be the image? The image is D. And that is the end of part 1 of the notes. So we'll stop and go on to part 2.